All right, today we're going to do geometric sequences. It says a sequence is geometric if the ratios of consecutive terms are the same. So what does that mean? Last time we talked about arithmetic sequences and we said the first differences were constant. Here they're saying the ratios are constant. So you would take the second term and divide it by the first term, and the third term divided by the second term, and those are all constant. So instead of finding the differences, you're dividing to find that common ratio. The nth term of the geometric sequence would be described by this formula. Again, on the test, you're going to be given the formula. You just need to be able to write it. To find the ratio, we divide those to get the r, which would go right here. This is the first term. That goes right here. And then our exponent is n minus 1. You've worked with this equation before. It's an exponential. We just got out of the exponential unit. All right, so finding ratios, terms, and formulas here. Find the common ratio for this sequence. We would take 9 and divide by 3, and that is 3. We take 27 and divide by 9, that is 3. We take 81 and divide by 27, that is 3. So we've got a common ratio here. So the R is equal to 3. For our second example here, it looks more complicated, but remember you've got a calculator, so it should not be any harder than the one you did before that. We would take our -4/5 and divide it by -4. If you can't remember how to divide fractions, use the calculator. So -4/5 divided by -4, and we get 0.2. Remember, you can hit math, enter, and change that to a fraction. So that is 1/5. Then we take our next two there. So 4 over 25 negative divided by -4/5 is 1/5. And so all of these are going to come out to be that 1/5. So there's our common ratio, 1/5 or 0.2, however you want to write that. Number 3 says find the 15th term of the geometric series whose first term is 20 and whose common ratio is 1.05. This is where we're going to use that formula to write the equation here. So we get AN is equal to our first term, which is 20. Our ratio is 1.05, and then n minus 1. There's our formula. You can then use that formula to find any term. To find our 15th term, we would plug in 15 for the n. Again, you have your calculator. We're not expecting you to do that in your head. So you can do 20 times 1.05 raised to 15 minus 1 you can put in there, or you can know that's 14, and we get 39.599. We're going to stick to the 3 decimals. All right, find the 12th term of the geometric sequence 5, 15, 45. Go ahead and pause the video there and then check your work for that one. It's similar to the one before. Find that ratio, find the first term, write the equation, and figure out what the 12th term is. Check your work here. You should have gotten that the ratio was 3 when you divided each one of these. And our beginning term was 5. That gives us this equation here. And then when you're looking for the 12th one, you plug in 12 for the n, and you find that it is 885,735. All right, for the next one, it says find the 6th term of the geometric sequence 6, -2 2/3. Again, don't worry about the fractions because you can use a calculator, but you're going to go ahead and take that -2 and divide by 6. And that is -1/3. So that's our ratio. Our first term then is 6. So our equation is 6 times -1/3 to the n minus 1. And so when we put this in the equation to find 6, we get 6 times -1/3 to the 6 minus 1. I'll show you how to put this in the calculator there. We get 6. If you want it to be a fraction, just like it looks like here, you're going to do alpha y equals numerator over denominator. That's -1/3. Close our parentheses, use the caret symbol, and raise that to the 6 minus 1, which is 5th power. And so we get -2/81. Remember, we're trying to leave our exact values, which is the fraction, not some kind of decimal that you have rounded. All right, the 4th term of a geometric sequence is 192, and the 8th term is 49,152. Find the ratio, the 1st term, the formula, and the 7th term. So this has a lot going on here, and this would definitely be one of the harder questions you have to do. What they've done is they've given us 2 points. They told us the 4th one is 192, and the 8th one is 49,152. To find the ratio here, since they are not in order, they're not consecutive, is a little bit harder. We take this 49,152 and divide it by 192. Again, don't worry about doing that in your head. You can't use the calculator for that one. So 256 is what you get there. Now that is not our ratio because we have 4 points in between here, because 8 minus 4 is equal to 4. So we need to do the 4th root of 256, because remember, it's multiplying times itself each time since it's an exponential. So the R would be 4. Now we found our ratio. The next thing we need to do is find our 1st term. So using either one of the points that we have, we do 192 is equal to, because that's the 4th point there, the initial, which we don't know. Our ratio is 4, and that was our 4th. So I'm going to do a 4 minus 1 in the exponent there. Sorry about that. There was a little glare there. Now we can do 4 raised to the 3rd power is 64. So we get 192, 64 times our initial amount. I divide by 64. And our initial amount is 3. So there is our initial amount. Now that we have our initial amount and our ratio, we can write our equation. That would be a 3 in the front, the 4 is the ratio, and minus 1. The last thing it tells us to do is to find the 7th term. Well, once you have the equation, you can find any term you would like. So to find the 7th, we just use that equation by plugging in the 7 for n. And so that tells us that our 7th term, we get 3 times 4 raised to the 6th power, 12,288 would be our 7th term. If you want to try that on your own, go ahead and pause it. That one was kind of hard, and so I think you need to see a second example, so I'll do one more of those. The 2nd term of a geometric sequence is -18, so they've given us the point to -18. The 5th term is 2/3. Find the ratio, the 1st term, the formula, and the 6th term. So I need to find our ratio here, so I take 2/3 and I divide it by -18. That gives me -1/27. Now remember, that's not the ratio because there are values in between these two. They're not consecutive. So 5 minus 2 gives me 3. So I need to take the cube root of this. For those of you that forgot how to take the cube root, it's in your calculator under math. So you're going to want to go to math. And then cube root is number 4 there. If you needed to take a higher root, then you would go to number 5. I can make that look exactly the way it does on my paper. That would be -1/27. And so that is -1/3. So our ratio is -1/3. Now, I still haven't figured out what the first term is. We have our second and our fifth, but we don't know what our first term is. So I can pick either one of these. I'm going to pick the one with the whole numbers just because I think it's going to be a little bit easier. So I do negative 18 is equal to our initial amount, which we're looking for. Our ratio is negative 1/3, and we're raising that to the n. This was 2 on that one, minus 1. Negative 1/3 to the 1 power is just negative 1/3. Now I can multiply both sides times negative 3 to finish that out, and that gives me 54 is equal to our initial amount. Once we have that information, 54 is equal to negative 1/3 to the n minus 1. So there is our equation. That would definitely be the hardest ones that you're going to get. You really had to think through that on a couple different levels. All right, the last thing we're going to talk about is the sum. Just like we did the sum with our arithmetic ones, we're going to do the sum with our geometric ones. It tells us that the sum for a finite geometric sequence with the common ratio that is unequal to 1 is given by this equation, just like we did with the other ones. So it says find the sum of the first 12 terms of the geometric sequence here. Just like with the other ones, you have to write the equation first. So that's what we're going to have to focus on. Now, our initial amount is right here. That's going to be our A1 because that's our first term. Then we just have to take that negative 1.5 and divide by negative 3. That gives me 1/2. If I take our next one here, negative 0.75, and divide by negative 1.5, again, we have 1/2. So our common ratio is 1/2. So sigma I is equal to 1. That's my first term. We want a partial sum of 12. So 12 is going to be the highest here. And then my equation is negative 3 is the A. That's our initial amount. Our ratio we just found to be 1/2 to the n minus 1. At this point, you would just want to put that in the calculator. You do not have to find the first 12 terms and add them up. So we put that sigma in just like we did with the arithmetic ones. That's at alpha window summation x and 1, and we want to go up to the 12th term, negative 3 times, and again, you can make it look exactly like it does on your paper by doing that numerator over denominator, raised to the x minus 1 power. And so there it is at negative 12285 over 2048. We've just found the 12th partial sum. All right, we'll do a little word problem here so you can practice one of those. It says a woman made $35,000 during her first year of her new job. Each subsequent year, she will earn 100% of the previous year's salary plus 15% in a raise. Find her total earnings during her first 5 years on this job. All right, so we said the initial amount is $35,000. The ratio here would be the 1 plus 0.15. That should look familiar. That's exactly what we did with exponential growth, the 100% plus the 15% raise, which is equal to 1.15. And so our equation is 35,000, 1.15 raised to the n minus 1. We use our sigma to indicate the first 5 years. And then you just put it in your calculator and you find that she made $235,983.34. All right, for the sum of an infinite, so we just talked about finite, those were the partial sums when you have a specific amount of terms. The infinite, remember, those are the ones that go on forever. If the rate is less than 1, then you can use this formula to find the sum. If it is not less than 1, then you are unable to find the sum. It does not exist. All right, So find the sum of the infinite geometric series here. We take our -6/2 and divide by -6 to find that ratio. And so our ratio here is 1/2. The first thing you need to do when you figure that out is see if it meets the criteria. And our criteria here is if that rate in absolute values is less than 1. So is 1/2 less than 1? The answer to that is yes, it is. So we can use this formula here, which tells us our initial amount, well, that's -6, over 1 minus our rate, which was 1/2. We plug that into the calculator and we find that it is -12. So that would be our sum of the infinite geometric sequence. All right, for our second one here, we divide 0.03 divided by 0.3, and we find that our ratio is 0.1. We ask ourselves, is 0.1 less than 1? The answer to that is yes. So we can use the formula. The formula will be given on the test. So our initial amount is 0.3, so that's going to go in the numerator, and then 1 minus the 0.1. That gives us 0.333 repeating. So for our answer, we would want to answer 1/3. Remember, we're sticking to the exact values, not a decimal approximation. So you would not want to write 0.333 because that is not correct, or 3/10. Neither one of those is correct. So don't write those. All right, for number 12 here, we have 3 plus 6 plus 12 plus 24. If you think about these, our ratio would be 2. 6 divided by 3, 12 divided by 6, 24 divided by 2. So we ask ourselves, is 2 less than 1? The answer is no. So we say the series diverges. So the sum does not exist. And then for our 13, it says use summation to write the sum of 7 plus 14 plus 28 plus ... to 896. So this is not an infinite because we do have a final term here. So this is a finite geometric series. Our initial amount is 7. 14 divided by 7 is 2. 28 divided by 14 is 2. So our R is 2. So our equation would be 7 times 2 to the n minus 1. Now, in order to write this sum with sigma, I see that I starts at 1, but we do not have a final here. So I need to find what term is that so that we have our final value. So I plug in 896 into my formula. And I solve for this n so that I know what term it is. And you can do that because we just did this in the last unit, solving for exponentials. We divide by 7. I need to free this n minus 1 out of the exponent. So I'm going to take the log, and I get log base 2 of 128 is equal to n minus 1. We drop the base, so the base on the exponentials, the base on the log, and then those switch. This is something that you can plug into the calculator. When you get the log base, you plug in the 2 for the base and the 128 for the argument, and we get 7. So n minus 1 is equal to 7. I add the 1, and I get 8. So 8 would be my final here. We want the 8th partial. So there is my formula for the sum of this sequence. So quick summary, The arithmetic ones are the linear ones. You're finding a constant first difference. The geometric, you're finding a constant ratio. So you're dividing. Thanks for watching.